this is the Cloud 101 session, so hopefully everyone in the room is here for that. My name is Annie Burgess. I'm the director of the ESIP lab, and I'm going to, we're going to start off with Mike Little talking a little bit about the motivation for this session. And after Mike, Amanda Tan will be leading everyone through a very hands-on exercise in introductory cloud computing. So this is really from setting up an account to hopefully getting into some data. So if you have a laptop, please make sure you have it open. I think there are some, I don't know if, I can't remember if we send instructions out, but making sure you have the terminal available. And I'm going to pass out some usernames for everyone, and I'm going to hand it over to Mike here.
Thanks, and I would like to take a few minutes and just see if there's anybody in the room who doesn't know, who's never touched cloud computing before. Okay, so we have a few. All right, good. Because when I look over and I see Thomas Huang sitting here, it's like, why do I even want to talk about this? I want to take a few minutes and explain why in my program we think cloud computing is not just cool, but really an effective tool. And so one of the major thrusts of my program, sorry, it's hard for me to do this without slides. Marge Cole, sitting over here, told me that I couldn't use the 65 slides that I had to go through. But in my program, there are two thrusts, the Advanced Information Systems Technology program. There are two thrusts that we're pursuing. One is a new observing strategy, which involves constellations of satellites, and there's actually some really cool cloud stuff going on in that area as well. But the other part of it is the Analytics Center framework, which is really about how you analyze data and derive scientific understanding of phenomena from the data that's been collected. Cloud computing really is a key element of trying to do this analysis. It's virtually impossible to do to analyze large sets of data today using the laptop approach that we've been using for the last 20 years. And so accessing large sets of data almost invariably requires large numbers of computers to do something with it. And cloud computing, the three major cloud providers, as well as a lot of the smaller cloud providers that are providing additional specialized services, are kind of instrumental in gaining access and analyzing this data and doing good science today. One of the advantages to using cloud computing is that you don't end up having to own the hardware, set up a facility, do all the computer security associated with it. You can rely on the work that other people have done. At NASA, we use managed cloud environments, which means that each of those different kinds of environments has a computer security authorization to operate to begin with, and it has some kind of a pay-as-you-go model, so that as you use more computation or more storage, it's paid for through some mechanism related to the study that you're conducting. We also, one of the advantages to using cloud computing is that you can set up a cloud environment outside of the government firewall for at NASA or NOAA or some of these other places, the other government agencies. You can be outside that security zone, which means that then you can actually share team-wide the computational and data assets, regardless of what country they come from, or regardless of what organization they belong to, as long as you could pay for it and give them access to that, to those resources, and then also have some kind of a security model so that the material that you're using maintains its integrity and it remains available. Those things are key elements of this. And cloud computing, as it's used today, almost universally provides you with ways to do that. One of the nice things about using cloud computing and containerization is that when you have when you have a set of tools that you want to share with other people, you can encapsulate those in a container and set that up so that it can be shared with others without then, those of you who have been supporting software for a long time, remember that when you give somebody else a software package and they want to install it on their computer, you probably spend as much time helping their configure their computer so that it can install that package and work as you did writing the code to begin with. So, you know, with cloud computing and then with containerization, you can distribute those capabilities, you can have them run, and most of the people that I work with that are using this mechanism for software distribution spend almost no time at all helping them to get installed and up and running. Then they can spend their time answering questions about the analytic tools and what they mean and the more important aspects of it. So I have about a dozen examples of programs that are using cloud computing today pretty extensively in earth science, including the Landsat program. NASA is in a couple of years going to launch a synthetic aperture radar satellite called NISAR in conjunction with the Indian Space Agency, and all of that processing is being done using cloud computing, and that's absolutely essential to being able to actually process enough of the data that it becomes a worthwhile investment. There are other examples as well, and I'm around, so if you want to talk some more about how other people are using this, I'm happy to talk further. And with that, I'll turn it over to Amanda.
How would I go like that? All right.
Great. Good morning, everyone. Hoping that works. Okay. So, okay, so just a brief introduction of why I'm up here. As I am actually a data scientist at the eScience Institute at the University of Washington, and formally, about 2 months ago, I was the cloud lead technology developer with UWIT, working in conjunction with the eScience Institute at the University of Washington. So before we begin, actually, I think Mike did a really good introduction, which I was going to touch on a little bit, but we're going to skip that because I think we're running a little short on time. So to begin, we are all going to try to log on to this Etherpad. So I'm hoping that everyone has their laptops out and that you have either a terminal on a Mac or you have a Windows bash going on. But anyway, if you can pull this up just on your browser, the link is HTTPS beta Etherpad. And if you're not familiar with an Etherpad, it is basically a Google Docs like environment for you to, anyone can log on and just start writing things on it. It's open, and people that have the link can actually edit it. So I will be posting, you can post questions here, you can post you know, comments, you can post instructions to your fellow participants on this Etherpad. I am actually going to not have this up the whole time, but if you ever need to refer to any kind of information for this hands-on tutorial, this is where you would go to. Again, before we begin, just make sure that you, if you're on a Linux machine, that you have your bash shell open. If you have a MacBook, please have your terminal open. We're going to just run simple, very simple bash commands. And if you have questions, please let me know. It's going to be kind of fast and intense, but we can take some time out to kind of just walk through things. And with that, also, I have notes here on this website if you wanted to follow along. And again, all the links that you would need is in this Etherpad, so have it handy at any time. There we go. So just a room check, questions? Okay, and we will start with this website. Again, the link is in the Etherpad. So to follow along, it's this link right here. These are the notes. And here we go. So again, I won't touch very much on the introduction. I actually wanted to get a show of hands of people who have or have not worked with the cloud, but I think that ship has sailed. So just very briefly, I just wanted to touch on things like why are we interested in using the cloud, right? So for me, some of the most amazing, one of the greatest analogies that I've ever come across is this analogy of cattle, not pets. So in traditional science, the way we've done computing in the past is that we have a server that sits under our desk. That one machine that if it goes away, if it dies, that's the end of our world. But with cloud computing, if you think about, all these computers that are sitting in a data center somewhere in North Virginia, and you have data centers that are in Portland, Oregon, and you start thinking about computers after computers, and you think about them as cattle, they're dispensable, right? If one of the computers die, you take them out back and you just either shoot them or you shut them down. So they're cattle. They're not pets. You don't name them. They're all the same. They're a whole bunch of cows. And if you think about the cows being your computers, that would give you an idea of how cloud computing works. And the other reason for moving to the cloud is, again, as Mike mentioned, that a lot of data sets, the larger data sets these days, are moving to the cloud. So for example, AWS already has a whole bunch of Landsat data stored on already has a whole bunch of Landsat data stored. There are about 6 advantages. There are probably more, but the main 6 advantages that are relevant to research 6 advantages that are relevant to research are the following. So the first thing is that you really do not have to wait for your computational tasks to start. So if you are used to traditional computing clusters, you would have come across instances where you are competing with other people in your department or other people in your university to start using those computing resources. Whereas on the cloud, because there are so many machines, right? There are so many it's cattle. You don't really have to wait. There's no wait time. And again, you don't have to purchase that hardware. It's not something that you pay $5,000 or $6,000 upfront for one machine that you then have to get a systems administrator to maintain. It's automatically done for you by the cloud providers. And because of that model, what it is that you pay as you go. You only pay for the resources that you use. And again, another big advantage is that huge scalability. And also with the cloud, you get a lot of community support. There are so many companies and so many institutions using it that you get that it's rapidly, technology is rapidly advancing in the cloud technology field. And the other thing that comes up a lot of times when people talk about cloud computing is this question of, is my data secure? Is it reliable? What if a data center falls over, if there's an earthquake in this region? The thing with a lot of the cloud providers is they kind of factor that in, right? So they have multiple data centers that are across regions over the United States. Globally, they have many data centers that they can replicate your data over. They have a lot of governance around data security. So those are just basically the 6 main advantages to get you to start thinking about maybe cloud would be suitable for my research. And there are also reasons to not migrate to the cloud. Some of the reasons would be if you already have a computing environment that works for you. If you are completely happy with what you have, don't move to the cloud, because that lift is sometimes not worth the effort. You have to learn a lot of things before you can start learning how to use the cloud. There's things about how to keep your account secure. There are lots of, it's not an easy port from the way that you've computed before to using the cloud. Then also, if you use your computers at a very high duty cycle, so for example, if you're doing a lot of machine learning, a lot of deep learning, and you are using GPUs 24 hours a day, the cloud might not be the most cost-effective option. And also the last one that is kind of really important is that if there are lots of administrative hurdles that you need to get around, so for example, like FERPA, HIPAA compliance, then it might not be worth your effort to move to the cloud. Okay, so I'm going to scroll through this a little bit more. Again, this website, you can read it. I'm just going to skip in the interest of time. Okay. I'm going to scroll down here and talk about why we're learning about AWS specifically today. So as a lot of you know, that there are actually three different, basically there are more than three, but the main three ones are AWS, Microsoft Azure, and Google Cloud Platform. And the reason why we're talking about AWS today is because I wanted to demonstrate how to access Lancet data on AWS. All three cloud providers provide a lot of similar services. So the big services that cloud providers give you are compute and storage. And they're basically pretty much similar across the board. It just depends on your needs. And again, it depends on where you're getting funding from. So for example, AWS gives out a lot of research credits, and that might be something that would keep you going towards AWS for your public cloud needs. Whereas if you have a grant from Google Cloud Platform, that might factor into which cloud provider you choose. So we are going to just dive right in. So the purpose of today's workshops are to understand first how to log on to the AWS console. We will spin up an EC2 instance. So an EC2 instance is a virtual machine. Can I get a show of hands of whether or not people understand what virtual machines are? Yes, great, excellent. I'm assuming everybody. If not, just please type it in the Etherpad. If you have questions, and Etherpad is mostly anonymous, so please just type in questions if you have any, and we can get around to that later. And we'll learn how to spin up an EC2 instance. We will walk through some of the parameters or some of the options that you can attach to a EC2 instance. We'll talk about something called roles, which basically is a security measure that I would strongly encourage everyone to learn about. Part of the problem with using a public cloud is that you get something called access keys. And there are lots of times, there's been times where people accidentally, push their access keys up to GitHub. And access keys are a way for the outside world, you, hopefully only you, get to communicate with things that you have provisioned on on your cloud, right? So like, for example, if you have an EC2 instance and you're trying to connect to it from, let's say, a Jupyter notebook, you would use something like an access keys. But there has been times where people have pushed those access keys up to GitHub, and within metaseconds, you can run up $15,000 in debt. So learning about those things is really important in getting started with the cloud. And then the other thing that you would learn today is how to create an S3 bucket from the command line instead of having to go into the console to create an S3 bucket. So S3 bucket is an object storage that you can store files in. And just again, sorry, show of hands of people, do you understand the differences between a file storage and an object storage? Okay, all right. So a file storage, if you think about it, like a Microsoft Word document, right? You can go through and you can edit, things word by word, letter by letter, and it doesn't save the entire file. It actually saves those changes, those very specific changes that you have made byte by byte. Whereas with object storage, it's different in that if you change something within that object, it saves it back as an entire object. It's not, you can't, for example, you can't take things out bit by bit, if that makes sense. So again, there are, of course, a lot of technology around enabling people to do the bit-by-bit reading of objects. And that's something that if you're interested in, there are lots of sessions that I think are happening that will talk about that as well. And then following this tutorial, there is a Pangeo Jupyter Hub tutorial where you would learn a little bit more about that. But yes, so S3, EC2 instances, and then we would learn also how to install packages on a virtual machine. So again, when you get a virtual machine on the cloud, it's completely empty. What it is, you don't have any programs on it. So you want to learn how to install certain programs that you would use so that you can actually start doing some work, right? And then the program that you would use would be, how many of you are familiar with Jupyter Notebooks? Yeah. Okay, so and then we would learn how to launch Jupyter Notebook from the cloud, have you access it through a web browser, and then just runs like some analysis. Okay, great. And everybody should have those little slips that look like this, so that you don't have to use your own AWS account. Okay, all right. And again, a lot of the notes that we will be going through, if you get lost, are here and also on the Etherpad. So, okay. So the first thing we're going to do is log on in your browser. I'm going to paste this link here. And if you get lost, please raise your hands. This is very hands-on, and we will take some time to address those problems. So, this is the link that you would go to. I don't know if that's too small. Again, it's in the Etherpad right here. And you should be at a page that looks something like this. And with your account ID would be UW eScience. Your username would be that username on the slip. So for me, it's ESIP user 1. Then the Great, and if you're logged on, you would see a page that looks like this. Again, if you're not in or if at any point, please stop. Please stop me. And we would go scroll down a little bit to this part called Build a Solution. Right now, we are going to click on Launch a Virtual Machine. Okay, and if you click on it, it should bring you to this page. So what I want to draw your attention to right now, for those of you that are already on this page, is this little tab right here on the top right corner that says, if you press on this little button, it comes down. I'll give you a whole list of geographic locations. That's something called regions. And you want to select, when you provision meaning when you start an AWS service, right? So like an EC2, or you start any kind of service, you want to make sure that the region that you have chosen is the closest region to, for example, other services that you have. So for example, if your S3 bucket that you've created is in US West 2, which is Oregon, you want to also create an EC2 instance in that same region. Why? Because if you're transferring data from different regions, so if let's say your S3 bucket is in US West 2, but you have an EC2 instance that is in Virginia, there is a very small transfer fee. And you want to make sure that you think about those things, about reducing costs when you do when you provision those services, when you start those services. And again, in that first website, you would see that the cost of storage, so S3 buckets have really minuscule charges for storage, but there's also charges when you start transferring data between regions. So that's something to keep in mind. And for today's workshop, we are going to just keep things in US East Ohio. The reason for that is because that's easy for me to clean up after you are done with today's lesson. And if everybody's on this page, we are going to scroll down and choose a machine image, an Ubuntu machine image. There we go. So we're going to choose the Ubuntu server. When you scroll down, you'll see that there are lots of operating systems that you can provision. Some of the operating systems are free. Some of the operating systems are not. So for example, like Windows machines will come with a license fee. I'm going to go ahead and select that. Okay. And you would come to the next step, which is asking you to choose what is this machine size that you want. So if you see here, you can see that they give you a list of how big those machines are in terms of CPU and memory. You can see that you can choose a machine that has, some of these machines are really large, but they cost a lot of money too. Again, I want to draw your attention that one of the things that is really nice about Google Cloud Platform, if you're interested in ever using it, is that when you come to a page that looks like this, they actually give you the cost. Whereas on AWS, you see that that's actually not a cost. So that's one of those things to keep in mind if you're thinking about, user friendliness, I guess is the term. But anyway, for today, we are going to use a T2 micro, which is the tiniest machine that you can get. You can do some stuff on it, but not a lot. But today we're just going to use that. So we're going to select right here, this button, and we're going to go next to configure your instance. And I'm going to spend a little bit of time going through this because if this is your first time with cloud computing, this is something that you should know about because it can help you cut your costs and it can help you with some of your security issues. So if you look here, there is this option here called request spot instances. So spot instances are virtual machines that are just sitting there in the data center that are not being used. And Amazon decided at some point, like, well, we have all these machines that are sitting there. How can we make money off of them? We will just let you have them for really, really cheap. All you need to do is tell me how much you're willing to pay for it. So it's kind of like a bidding mechanism. It's eBay for virtual machines. And if you are running jobs where you don't need to have 100% uptime for your computer, that your computer doesn't need to be on all the time, because spot instances you can get kicked off of the virtual machine if you provision a spot instance. So what happens is that you give Amazon a bid. Let's say you say, okay, I'm going to bid 1 cent per hour on this instance, whereas the actual cost of that instance is 10 cents. So if you get that instance at 1 cent for a whole day, you're only paying 24 cents. Whereas if you were paying full price and not using a spot instance, you would be paying 240. Yeah. So, but if more and more people start bidding on those instances, the prices keep going up. So again, it's like an auction style virtual machine provisioning. And the next thing we're going to select here is, if you see here, there's something called a VPC. So what a VPC is a way to keep all your instances kind of talking to each other within, it's called virtual private cloud. It's just a networking terminology that helps you keep all, for example, if you want to limit your virtual machines to only certain IP addresses can log in, right? This is where you would do it. But today we're not really going to touch on that because it's a whole other can of worms. And then the other thing is that we want to make sure that we use the subnet setting and enable public IP. So public IP would allow you to log into your virtual machine via SSH, so secure shell. from anywhere you are. So you don't have to be confined to, for example, only your institution. You can actually log onto your virtual machine from your home. So we're going to enable that. And then some of these terms, so for example, capacity reservation, you can actually reserve instances, but at a higher rate in only certain regions, right? So if you say like, oh, I want to only have machines in US West 2C. So US West 2C is very specific. It's very specific to a very specific data center. And you say, I only want machines from there. This is the checkbox that you would take. And then previously, if you remember, I mentioned IAM role. So if there's one takeaway that you have from today is that IAM roles are really, really important in AWS. So what's an IAM role? Again, it allows you or your user to kind of communicate with services that are on AWS. A lot of times you can limit what a person can do. So for example, today I created accounts for all of you, but I limited your access to other kinds of services that I don't want you using. So for example, I don't want you running up GPUs on the Amazon machine learning service, right? So I would lock you down and I would say, no, that's not a service that you can use. So today you have access to creating S3 buckets, you have access to running EC2 instances, and you have access to listing the IAM roles. That's it. So there's nothing else that you can do, hopefully. And also the other thing that was, so hopefully that's clear with IAM roles. I feel like I'm speeding through. Okay, so here on the IAM role, if you scroll down a little bit, this is a whole bunch of IAM roles. You would see here that something called ESIP S3 full access. So this is a role that I've created that would allow the virtual machine that you create in the next few steps to talk to an S3 bucket. So we're going to select that. And then we're going to keep the shutdown behavior at stop. Sometimes teaching Cloud 101 classes, people get confused between stop and terminate. So when you stop your instance, it's just like you closing your laptop, right? Some of the processes, a lot of the processes stop, but your data is still stored there. And you get charged for that. So when you stop an instance, you don't get charged for that virtual machine that you've provisioned. So again, like the example that I gave, if your virtual machine costs 10 cents per hour to rent, you are not going to get charged for that. But you would get charged for the data that is stored on the virtual machine. So right now, the data that's stored on a virtual machine costs you 10 cents per gigabyte per month. So that's when you stop. When you terminate, it's equivalent to shutting down your laptop and throwing it away. So everything gets lost. That way you won't actually get charged for anything. You get zero, but your data gets lost on that virtual machine. So we're going to keep this shutdown behavior at stop. And the other thing, just really going through this really quickly, enabling termination protection is just that in case somebody decides to terminate your instance, there will be a pop-up that says, are you sure you want to do this? Termination protection has been enabled. So it's like a two-step process instead of just being able to terminate it and that's the end of your machine. And then monitoring, if you enable CloudWatch monitoring, it's basically a service that AWS provides to you to help you keep track of things like usage and cost and CPU limits. And then tenancy is whether or not you want to have your own dedicated space on a rack space in the data center, or you are willing to share with other people, right? So if this space on the data center is, for example, 256 CPUs, you'd be sharing it with other people, or if you want the whole thing to yourself. And then also there's something called T2, T3 unlimited. So if you remembered when we provisioned the EC2 instance, we provisioned a T2 micro. So T2 micro is the tiniest virtual machine that you can get. But if you enable this T2, T3 unlimited button, you can actually get more CPUs and more memory as needed. So you're actually not paying for a lot upfront, but if your programs run over, 1 CPU or 1 GB of RAM, then you actually can get more CPU power and more RAM. So, but we're just going to leave that. And then we're next going to go to storage. So this is the root storage on your machine. So what you would install in the root storage usually are things like your operating system, things like packages and programs. You try not to store data on your root storage. Why is that? Because if you terminate your instance, your root storage goes away, right? If you attach, so for example, if you click on this button here that says add new volume, right? This means that you are getting, for example, in reality, that it's like equivalent to getting a additional hard drive that you can just plug into your laptop. So you can always take out that hard drive, you can always take out that EBS volume, and you can store it somewhere. So you want to make sure that in order to architect something on the cloud, you would think about storing a data separate from your root volume. Okay, questions? Okay, great. For today, I'm actually not going to do that. I'm going to take that out, and we are going to just work with a root volume, and we are going to change that root volume to 25 gigabytes. And then we're going to click Next, Add Tags. Okay, and there's also a little bit of confusion sometimes around what purpose tags serve other than to be annoying when you have to key them in. So tags are really important for you to keep track of your resources. So right here, if you add a tag, and you can see that there's a key and a value, right? A key, the parameters that you can put into the key are kind of defined by AWS themselves as a way for them to track your resources. So for example, if you say name, that will assign a name to your virtual machine. And here the value that we are going to use is ESIP user 1. For me, so for you, it would be ESIP user 11 or ESIP user 15, whatever that your username was, you should use that. And please append ESIP to everything that you do today, so that's easy again for cleanup. And we are going to add another tag called owner. And that is ESIP user 1 again. And that is so that if there were any runaway costs, I would kind of know who to track down. Okay, so that, if that's great. Next, we would go to a security group. So we talked about VPCs. Security groups are, again, another layer of security for your cloud machines. Here it tells you what ports you can open. So ports are ways for the outside world to talk to your virtual machine. And here you can see that the SSH port is open, port 22. So that will allow you on your terminal from your computer to actually SSH into your virtual machine. The other thing we're going to add here, if you add a rule, is we're going to open up port 888. And that is a port for you to connect to your Jupyter notebook when you eventually do install it. And you can see here that it wants a CIDR, SCIDR, a CIDR block, or an IP address. And we're just going to copy this value and stick it in there. It just means that it's open to the world. A lot of times, if you want to add a layer of security around your cloud instances, you would start having to be more specific about IP addresses. Okay, great. And actually, I apologize. I actually created a security group for everyone. And you can select it here. If you scroll back up on this page, still on this page, and you select an existing security group, you scroll back up, and you can find that there is actually a security group called ESIP-SG. And you click on it. You should see that in the rules, again, a lot of the same ports are open. Yeah. It's called ESIP-SG. Great. Okay, moving on. And if you're past that, yes. You're not seeing that. So it's under name. It probably, if you sort it by name, it should show up. If you, so if you are running into that problem, it's okay. You can also just create a new security group and put in port and make sure that port 8888 and port 22 are there, right? And stick in the CIDR block. If you can't find it, that's fine. You can just create a new security group. Okay. And then I'm going to move on. And I'm going to go to review and launch. And so this would give you a overview of what you have provisioned, what services that you have requested. So just to double check, we have an Ubuntu server. And here you'll see something called AMI. So what that stands for is Amazon Machine Image. If you remember when I said previously that when you shut down your instance or when you terminate your instance, everything goes away. There is a fail-safe protocol that you can do, which is to create something called a snapshot, right? So you take a copy of your whatever that's on your machine and you create a snapshot. And what it does is basically it takes a picture of how your virtual machine looks at that time. All the packages that you install, all the data that you have, it compacts it into some kind of metadata. It dehydrates it and it stores it into something. It's a snapshot that's stored on S3 bucket. And you can create something called an AMI, which is an Amazon Machine Image from that snapshot. And it allows other people, for example, if you give them, you say, okay, so, I have this snapshot of my computer, what it looks at that time, and I want to give you this AMI. That person can actually reproduce that particular snapshot that you had at that time. That makes sense? Okay. All right. So this is an AMI that Amazon has created that has Ubuntu installed on it, and that's what we're using to create our virtual machine. And we have a 2.2 micro, we have a security group, ESIP-SG, which has port 22, port 888, and port 80, which is for HTTP access enabled. This is an overview. And then if you click on, these are just a recap of what you have provisioned. And we are going to go to launch. Okay, so is everybody at the screen? Okay, great. What you want to do is to create a new key pair. So that key pair will allow you to actually SSH into your virtual machine. And you want to, again, append ESIP to anything that you write on the AWS console. So here, my key pair name would be ESIP user 1. Okay. And I want to make sure I download it. Okay. And I'm going to save this file. Okay, great. And once you are past the step and you have saved your file, you will launch your instance. Okay, and you should be at this page. If you're not and it gives you some error, please let me know, because sometimes it gets freaked out if like 40 people logging in at the same time, creating instances at the same time. Okay, and once you're on this page, to go and see the status of that machine that you have provisioned, you would click here, right? So you have a link that is the ID of your machine. And you can see here that I have one and it says it's running. The key pair, you would select create a new key pair, create a new key pair button, and then it should give you a space to type in the name of the key pair that you want to create. Okay, great. And so if everybody's on this page, save. Yes, you need to download it. You opened it though. Do you have it open though? Oh dear. Oh dear. Okay. Let's take 1 minute. Maybe you can breeze through the other like 7 steps that we've done. Would you be able to do that? Can we just take 1 minute for questions maybe and just wait for you? Or should we just blast through it? Actually, no. So what you can do is use that same ID and go through the steps again of launching that virtual machine. So you would, so again, if you're not back on your main page where there was like that launch virtual machine button, under services right here, you can see that these are all the services that AWS gives you. It's a lot. But what we're interested in is this EC2, right? And it would take you to a list of instances. So I see here there's 16 running instances. So 16 of you have actually managed to get a virtual machine. Hang on. So if you scroll down, you can see launch instance, and it'll take you back to that first, right? The first step that you would do to create a virtual machine. Go ahead. Okay, great. I'm going to go ahead. Okay. Right. Okay. So again, to go back to the list of the virtual machines, I would go to services, EC2, and if I click here, I can see that I have 16 virtual machines going. Oh, good grief. Okay, sorted by name, and I can see that mine is here, right? So I'm ECIP user 1, and I can see everybody did a wonderful job of appending names to your instances. I guess 3 are missing. But anyway, if you have a way to find it back, that would be great. Otherwise, yeah, I'm just going to leave that. So mine is ECIP user 1, right? Okay, so what the next step that we have to do is to make a note. If you're on this page, make a note here of this value, your public IP. Okay. All right, great. I think this is going to be the part where there's going to be a divergence of, okay. So again, I'm going to check in every 2 or 3 minutes. Please raise your hands if you're lost. It's better to kind of catch it before we go too far down the rabbit hole. Okay, so I'm assuming that everybody's okay. Please, again, let me know if it doesn't work for you. So we want to make sure that we make note of this. This is the public IP, which is will enable your SSH access to your virtual machine. This is the IP of your virtual machine. Okay, so we're going to, yes. Oh, okay. So if your IPv4 field is blank, it meant that you skipped 1 step. So if your IPv4 field is missing, if you remembered when we provisioned that instance, we had selected from a drop-down menu that said enable public IP, and it said subnet setting enabled. That was the one that you needed to make sure that was selected. So if you can walk through the steps again, all the steps for provisioning an instance is right here on this website. So if you're a little bit lost, please always refer back to this. You can walk through this, and it might be a little bit confusing, but use the Etherpad if you have questions. And again, we can touch base after this as well. But for the rest of the other, but for the interest of time and for the rest of the participants, I'm going to move on. Does that work? Okay, great. All right. So I'm also kind of lost. Okay, so now we're going to switch gears a little bit. We are going to pull up the terminal. We are going to pull up your Linux bash shell. We are going to pull up your Windows bash. Okay, so for me, I'm going to pull up my terminal, and my terminal looks like this. Okay, and again, sorry, show of hands. Is everyone familiar with Unix commands? Okay, all right, I'm just gonna assume that everyone's familiar with Unix commands, but this is like simple Unix commands that will get you through to logging onto your instance. So I'm gonna check where I am right now on my machine. So this terminal is open on my MacBook, and I am in users and Manhattan, and I know that I downloaded my key to my home directory /Manhattan/downloads. So this is my home directory, and I'm doing ls. Oh, okay. ls is just list the contents of the directory, and I'm going to change directory, which is a cd, into my downloads. And I'm going to do another list. And you can see that I have a whole bunch of crap in there, but I'm going to select, again, I'm going to list in order of stuff that I just downloaded, right? So the command for that is ls-lrt, which is listing all the contents in reverse order of time. And I can see here that I have my PEM key, which I downloaded, which I guess you missed a step. But if you have that, it would be downloaded. So make sure that you know where you downloaded this key to. And the next thing we want to do is change permissions. So we want to kind of lock down this key to be read only. I don't know if you can see. Let me scroll up a little bit. Here. Okay. All right. So I'm right here. And it's chmod 400, which makes that file read only. And I want to do this. Again, if you're not familiar with Unix commands, you can use tab to kind of fill out the rest of the file name. So here I'm going to do chmod esip-esip user1.pem, which is my PEM key, right? And if I type enter, okay. All right. So once I've changed the permissions on that file, I'm going to try to use that key to SSH into my virtual machine. So I would use a command that looks something like this. I would give it, I would say, please use this key. And I would say, look, I want to log in as Ubuntu to my server. And I would get that IP address from here, right? That's the public IP. Oops, sorry. Sorry, okay. And I would stick it in here. So if that works and I press enter, I'm into my virtual machine. Again, that IP address is what is specific to you, right? Is that IP address for your virtual machine. It's not my IP address. Okay, great. Okay, and it would say, yes, I want to continue. Freaking out. Great, you should see something that looks like this. Okay, I need some success stories. So people that are in, thumbs up. Oh my gosh, only 4, 5, 6. Okay, thumbs up. Yes, great, excellent. I'm going to go with that to win. Okay. All right. The people that are not in yet, is there a hiccup or? Is there a hiccup? The connection got closed. Oh, yeah, I think if somebody else that can help, if there's a person that's sitting near you that knows what to do, that'd be great. Otherwise, I can walk there. And again, if there's something that there was a problem they ran into. So the chmod 400 of the exact name of your file. Okay.
And encourage it, people, it's working for some people, we can move up it. If you want to look onto someone's computer just to follow along, you could also find a buddy that.
Right, and if this is going too slow for you, again, if you want to pace yourself, the notes of what we are going to do, all the next steps that you want to blitz through or power through, they're all on that website. Okay, so I'm just going to continue on, assuming that people are here and this Ubuntu. So this is actually the virtual machine that you've provisioned on the cloud. You're there. It's an Ubuntu machine. The next step that we want to do is to install some packages. We are going to install Miniconda, and I'm assuming that most people are familiar with Anaconda, which is a Python package manager. We're going to install Miniconda. So we are going to wget, and I'm going to have to pull up the notes so that I can actually copy it from there. Okay. Up. Oh, actually, you know what? Before we do Miniconda, I skipped like 10 steps. We're going to actually create an S3 bucket. So let's forget about Miniconda for a bit. We are going to install the AWS CLI. So the AWS CLI is a programmatic way on your instance to talk to communicate with AWS, right? So you can do everything with AWS CLI, from provisioning an instance, you can say create instance, or creating an S3 bucket. And it's a good way for you to learn, it's good for you to learn this, because as you progress more in your cloud pathway, cloud computing pathway, you would find that you need to rely on your console less and less. So the first thing we're going to do is actually to install the AWS CLI, and the easiest way to do that is using sudo apt-get AWS CLI. I ran into an error. Why was that? Because I actually did an update. So when you provision this new instance, again, like if you remember that I said everything is empty, right? You have nothing on it. So what you want to do every time you provision a new instance is to do sudo apt update. You want to update the entire virtual machine, right? You want to say, I want to get, start getting new URLs for where I can download my packages. So if you do sudo apt update, you would run into this. Again, sudo apt update if you want to following along. And after you get through this, you want to do an upgrade of the packages that you can actually upgrade. So again, sudo apt upgrade, and it would give you some prompts, and you would walk through that, right? And it's going to take maybe 30 seconds. Okay, I'm actually, while this is going on, and I'm guessing some people are also doing this, are there any questions? Is anyone stuck and needs help? Okay. All right, so again, the commands are sudo apt update, and then sudo apt upgrade. And then once that's complete, we want to do sudo apt get AWS CLI. Oh, maybe it's sudo apt dash get. Okay, thank you. Apt get. Ah, why is that? Oh, apt get install. Good. Thank you for pointing that out. Yes, thank you. Okay, yes. Forget. Sometimes it's yum, and it's like, yeah. Okay. All right. So again, once you're done the sudo update, sudo upgrade, then it's sudo apt-get install AWS CLI to get to this page. Great. So if you've installed your AWS CLI and you type AWS, you'll see that, oh, it's freaking out because now you have the CLI and it wants a whole bunch of other commands. Then the next step that we're going to do once we have the CLI, I'm just going to give it 30 more seconds. Is we are going to do something that looks like this. We're going to say, let's talk to AWS. We're going to do S3, make a bucket. And we're going to say, okay, I want to create a bucket called ESIP user 1. Okay, I press enter. I should say make bucket. So bucket's been made. So if you remember earlier on when we provisioned the instance, we talked about roles. So if you didn't specify a particular role, you would do something that went like this. And you don't have to follow along. This is just a demonstration. You would say AWS configure, and it would ask you for your access key ID, and then it would ask you for the secret access code. That is where you would specify those keys that you get from your account. And again, this is where a lot of times if you are, not careful, these keys can get out like to things like GitHub, and that's where all the problems happen. So we want to avoid you having to do this. Okay, so again, so now we would want to check if that S3 bucket is there on the list of all the buckets in my account. So I would do something like AWS S3 LS. You can see that, oh my gosh, there's so many buckets here. And we have ESIP. So we have 5 buckets, right? So we can see that it's there. So I created mine, ESIP user 1, that's mine. Again, the command to look at all the buckets there in the account is AWS S3 LS. So that's, again, very similar to Unix commands. The next thing we want to do is to kind of copy some files into that bucket. So where we would be copying the files from. So how many are familiar with Landsat data on AWS? Okay, so AWS hosts a lot of Landsat data publicly. It's hosted on their S3 bucket, and if you go to this URL, Landsat on AWS.com, I know it's really small. Oh no, it's not making that bad. Anyway, it's Landsat on AWS.com, right? It'll bring you to the public repository for all the Landsat data that's stored on AWS. What we're going to do in this next step is to copy a Landsat TIFF file, a cloud optimized GeoTIFF, from the Landsat S3 bucket, from the AWS S3 bucket that has all these Landsat data into our own bucket. Okay, so you can explore the Landsat imagery. You can click on that and it will tell you the Landsat rows. And for example, if I wanted to look at somewhere in California, I would go to row 42. What's that? Did I just, where did I go? Oh, here. Right, so I've looked at something like that. Actually, sorry, I accidentally clicked. What's that path? 42. Here, 42, and then I would go to row, for example, 23, and they would give me a snapshot of what's stored in that S3 bucket. So this is a browser way of looking at the Landsat data on AWS, but all these data is stored in an S3 bucket. So if we go back to our terminal right here, I'm going to do something like AWS S3 copy. I am actually going to copy the Landsat data from the publicly available S3 bucket that AWS has. And this is where all the Landsat data is stored. And I'm going to pull up my notes again. because it's a really long URL. And I'm going to copy that. So again, if you want to go back to the notes, and I'm going to stick this in the Etherpad too. This is the command if you need to copy. There. You can stick that into your terminal. Right here. There. And I'm going to change this to user 1. Again, if you just need to stick that in, if you don't want to type everything, it's in the Etherpad. You can just copy that and stick that into your terminal. Great. Okay, moving on. So if you press enter, there it is. And now I want to list the contents of my S3 bucket, right? I want to make sure that it's been copied there. Again, if you remember, it's S3 list. And this time I'm going to give it the name of my S3 bucket. Oh, it's not there. Why is that? Yeah, there we go. If that didn't work for you, you might want to take out that recursive. So if you see here, now it's downloading. Yes. To repeat, if it didn't work for you, if you did the AWS S3 LS, your bucket name, nothing shows up, repeat the command for the copy, but take out the recursive. So you want to repeat this command, but don't have the -- recursive at the end. Okay, so that should work. So again, if you do that, then if you do the AWS LS S3, you would see that there's actually a file in there. Okay, yes. Okay, so if you're there, just get out of it. So you would do a Control-C because we're not going to mess around with that. Okay, you're stuck there. Yeah, so oh, you can't make the bucket. No. Okay. Oh, so the probable, like I'm 98.7% sure of why you can't make the bucket is because you didn't select the role. If you remember in the step that when you created your instance, there was select a role, IAM role, right? ESIP S3 full access. That was what you had to select. So then you would get rid of this need to do the configure. So sorry, you're gonna be stuck there unless you want to walk through the whole thing, but feel free. So you have this account for the next 24 hours. If you want to walk through again, I would say go nuts, but don't. Just you can start doing provisioning instances again if you wanted to. But right here, maybe I should just breeze through and just interest in time. Yeah, okay, so I'm just going to breeze through. If you're stuck, just watch the screen. There's some pretty, at least to me, I'm really excited about stuff coming up. So I have this file, this TIFF file in my S3 bucket, right? I've copied it from the general public Landsat AWS bucket. So the next thing I want to do, now that I've copied some files, I've created an S3 bucket, is I want to install some packages on my virtual machine. So I want to install Miniconda. So I'm going to go to wget, and again, I'm going to pull up my notes. So for a quick copy. So now we're actually already in the third part of it. We're going to say wget Miniconda. Okay, it's going to download. And then I'm going to say, I'm going to do an ls. It's right there on my desktop, right? So I wget, so I'm downloading it from the internet, right? This link, Miniconda link. And I'm going to say bash, right? And it's going to say, okay, do you want to install Miniconda? And I'm going to go press enter, and I'm going to scroll through this. It's all a bunch of licensing. And I say, yes, I accept the license terms. And it's going to say, where do you want to install Miniconda? I'm going to go ahead and keep it in the home directory. Again, if you need to follow it through, it's in the notes. And it's going to install. So what we've done so far is we've launched an instance, right? We've talked about roles. We've talked about machine sizes. We've talked about S3 buckets, how to create S3 buckets programmatically from an instance that you have on AWS from a virtual machine. Then we are going to install some packages so that we can actually start doing some work. And I'm going to say yes. So I'm using Miniconda, which is a very, very part down version of Anaconda. And what I want to do here is to create an environment. So I'm not going to go too much into what environments are, but I want to create an Conda environment, which is kind of a self-contained sandbox of packages that would just be installed in this particular environment. So I would do conda create -n. I would give it a name. I would give my environment a name. I would say it's ESIP. And I want this environment to be Python 3.7. Okay, so if you run into a problem like this, it's mostly because there is a missing step somewhere along the way. So the way Conda is being referenced is in an environment path, and I want to make sure that my computer is updated with the latest environment path so that it knows where Conda is. So I want to do something like this, .bash rc, and if I run Conda again, it should work. There. And it's going to install a sandbox environment, a Conda environment with Python 3.7 in it. Okay, so then I want to activate that environment. I want to make sure that I'm actually working in that environment. So I say something like, you know what, I'm just going to push this down. So I say something like Conda activate ESUP. Right. And I want to install a whole bunch of packages in here. So I want to install raster.io. Is everyone familiar with raster.io? Okay, I'm going to install So raster.io is a Python package to work with raster files. Raster.io, I'm going to install matplotlib. I am going to install Bodo3. So Bodo3 is a Python package for access through it's a developer kit for talking to AWS services. It's a Python package. So I'm going to install Bodo3, and I'm going to do that. Okay. It's going to go through the steps, and I'm going to say yes. So right now I'm installing a whole bunch of packages within this ESIP environment, Conda environment that I've created. And also, I think this would be a really good time to kind of plug, if you're not familiar with software carpentry, the website here, I'm going to stick it in the Etherpad right here. So software carpentry is a standard workshop that walks through everything from getting you started with open reproducible science. So it walks you through tutorials of learning how to use GitHub, talking about how you get started with Python. It talks a lot about, Conda and data science tools. So software carpentry, I can stick in the URL later. But back to our terminal, it's still installing. Okay. So this might be a good time to, if anyone had any questions that was not even related to running stuff, like general cloud computing questions, data science questions. Yes. Yes. How do we close things up? On your end or on your end? So you would log out of that instance. So you would type something like on your terminal, you would say exit. You would get out of that, and then you're good. But on the AWS side, you would want to go back to the console, right? And you want to click on your instance. So for example, for me, it's ESIP user test one, ESIP user one. I would go there and I would say shut down and walk through the steps. It should be fine. This is, I feel like this is taking an inordinately long time to download stuff.
This is going to be the test of the public Wi-Fi.
I think it's broken, actually. I actually think it's broken. Okay. Oh, there. It's alive again. Okay.
That's true.
Well, I think if it's printing the screen though, right? Yeah. Okay, I want to make sure. Okay, so you can check what packages are installed now in this environment, and I want to do something like conda list. I hope I didn't break anything. Okay, and then next thing that I want to install is conda install Jupyter Notebooks. So this is, okay, Jupyter Notebook. Should take 30 seconds. Jupyter Dash Notebooks. I think, I don't know if this seems like it's touch and go with this instance. Okay, so while that's installing, so what I wanted to do with the next step was walk you through how you can pull up a Jupyter Notebook on your instance. But this seems to have stalled for some reason. Let's try it again. Set Jupyter Notebooks. Yeah, so it's Jupyter Notebook. Yeah. Ah, there we go. Okay. Great. Okay, now we can actually do fun stuff in the last 5 minutes. So we would do something like Jupyter Notebook, okay? And again, remember that this is actually on your AWS instance, but I want to, run Jupyter Notebook on my own laptop. So I would do something that looks like this, equals to, and this is just telling the AWS instance that launches that Jupyter Notebook server that anybody else, any IP address can actually ping it, right? So this is what you would do. Oh, and it says, okay, copy and paste one of these URLs. So if you remember that we had a public IP address. That's why you want to provision one. So if I go back to my EC2 console, my AWS console, and I copy that, and I stick it into a browser, right? And I copy this part. So it says here, copy and paste one of these URLs right here. And this is the URL that you would actually use in your browser to connect to your Jupyter Notebook. So I would copy this whole part right here, and I would stick that in there. And look, I have a Jupyter Notebook, right? And so again, because we are provisioning a really small instance, there's really nothing much you can do on a small instance. But if you have like 64 CPUs and you're running a Jupyter Notebook, you can actually work with large amounts of gridded data sets. So if like you were running out of RAM on your laptop with running something like Xarray, you could go to the cloud and you could provision a super big instance, and then you would get your job. Ideally, you would get your job done in no time. So the final thing that I wanted to walk through was to basically, I'm going to just upload a notebook, this one. Okay, you can upload a notebook to the Jupyter notebook server, and you can say upload, right? And now I have an IPython notebook right there. And this is basically a very simple Jupyter notebook that my colleague Scott Henderson developed specifically for a hack week at the University of Washington. For this instance, this is again a shameless plug for hack weeks that's always hosted by the eScience Institute at the University of Washington. This is the GeoHack Week, where it's people coming together from institutions across the United States and internationally to come and work on data science problems. They will learn tools like GitHub, Python, raster processing tools. So it's just, you know, if you're interested in coming together with other researchers to work on problems together, this is a good avenue. So it's GeoHack Week. But here, again, I'm going to walk through this Jupyter Notebook really quickly. I'm going to import those packages that we installed. We're going to run this, and it says no module name raster.io. I think I broke it somewhere. Okay. Okay, I'm not even going to attempt to fix this because I think when it installed just now, it didn't install. So I'm just going to walk through what this notebook has in it. So I'm going to import all these packages that I've installed in that environment. And I'm actually going to store, I don't know if this is too small. Okay, so again, you see here that I can read and store these images directly into a variable, right, directly from the S3 bucket. So I'm saying that, okay, I'm going to grab the red band image directly from this S3 bucket, the Landsat bucket, and I'm going to grab the near infrared image directly from this S3 bucket, right? And with raster.io, I am going to open these images. And what you would see really are images. I'm going to open Scott's one. I hope I can see it. Okay. It's actually not running. That's fine. So what you would see is actually a plot. So you can plot using raster.io directly from S3, right? And you can also plot the near infrared directly from S3. So ideally, if this all was working with no hiccups, you would see plots. And you can do quick NDVI calculation directly from the images that you've already stored. And you would save that image, okay? You would save that image. And the next thing that I wanted to teach you, but I guess we're running out of time and it doesn't work, is that you can actually use this. So remember that I mentioned something called Bodo3, which is a Python package for talking to AWS. You would use Bodo3 to kind of dump that image, the NDVI calculation image raster that you have, the TIFF file that you have, back into S3. So this is kind of a workflow that you can use once you're on the cloud. Obviously, there's a lot more complicated, complex stuff that you can do, but this is just an example of how you would build that pipeline on the cloud, right? And yeah. yeah, hopefully I can get this to work, but so I have 3 minutes, and yeah. So if you have questions or comments, and you want to remain anonymous, you can dump them in the Etherpad. Otherwise, you can ask questions now, and I will be here. And so if you're interested in looking at how these images actually render, Scott Henderson will be presenting the tutorial on Jupyter Hub PNGO. A lot of stuff that I've shown in this Jupyter notebook is actually, I shamelessly copied from him. So if you want to see what this stuff looks like, just attend the next session. Yeah, okay, great. Yes, question, comments? Yes. Yeah. Broke it. The notebook's broken. Is it this one, right? You downloaded it from the GitHub. Oh, okay. So if you're downloading it from GitHub, you have to like have it like there's a raw format that you have to download it in. Otherwise, it won't work. So maybe we can touch base like after this, and I can swing by and help you. Okay. Yes. Yeah. That is a good suggestion. Yeah. Okay. Okay. Yeah.
Manual patching software is actually kind of dangerous because there's no reproducibility. You type a bunch of commands, you cannot reproduce them. We orchestrate all that through containers, and so when there's a bug on the software, we make the fix to the software, and we push it to our GitHub, and we generate a new container image of that software, and we throw away the old container that was deployed and just slide in a new version of the container. So there's no manual hands touches. So this is all about orchestration and reproducibility. So that's something that you can think about for people who might be a little bit overwhelmed for doing some of this. Is great, getting your hands dirty. To be frank, on my work is I actually have an SA can help me do a lot of the security part that I didn't have to deal with. And another part is really that everybody got their own security policy. So we don't really have the luxury of spinning up our own VM at my work. I think she just got into trouble for trying to do that because she was running JPL VPN and JPL blocker. But just think about your local security requirements too when you're running a cloud. Because so like for JPL, we have public cloud account, but every VM we generate is actually owned by JPL. So it has to conform to JPL security policy, access rules, and all that stuff. So if you're working in an organization, you might want to also check with that as well. So
can I just follow up really quickly on that? So I think for this, you can see how much effort it actually takes, if you were trying to go really bare bones. And I agree that like we should have AMI images specific to the workshop. So it'd be great for you to attend the next session. I know I'm shamelessly plugging this because of how hard it is for researchers who don't have time to actually start working on cloud computing, that there are research groups that are coming up with ways to abstract all this, right? So right now, for example, the Pangeo project, they're thinking about like, let's not even talk about VMs. How do we get the scalability out to people just via a Jupyter Hub interface, right? So you don't even have to think about, you know, installing Jupyter notebooks or packages. That's all taken care of. All you have to do is log on to a Jupyter Hub and you can harness the power of the cloud. So following up with that comment and plugging for Scott Henderson's session. Okay, the end. Okay,
Great.
thank you.
Well, I think, thank you, Amanda, so much for walking everyone through. Hopefully it has given everyone, at least for the rest of the week, if you're not familiar with cloud computing, a language that you now speak, at least in some part, that you kind of, when people are giving those demonstrations like we saw in the plenary, a little bit about the infrastructure that's needed to go into that in this, you know, little kind of way. And I would encourage, like Amanda said, the GeoHack Weeks that eScience do are fantastic. Software carpentry, there are a lot of avenues that can help people get going in cloud computing, especially if you are in that kind of physical science realm that can see the benefits of cloud computing and you want to be part of the club, that there are lots of ways to get there. So thanks again to Amanda. The next session on Pangeo will also be fantastic and in this room. And if you have any questions, again, yeah, the Etherpad, or find Amanda. Are you going to be here the rest of today? Okay, find Amanda today. So thanks everyone. Enjoy lunch.